It's 7:45 on February 21st, 1945. On the black volcanic sands of Iwo Jima, a single M4 Sherman tank lurches toward a Japanese pillbox. Inside the sweating steel hull, Electrician's mate second class Joseph Kissel is doing something no electrician in naval history has ever done. He isn't fixing a circuit breaker on a battleship. He is charging a fortified bunker in a weapon he built with his own hands. But this is no ordinary Sherman. The 75mm main gun has been gutted. The ammunition racks are gone. In their place, sloshing right next to Kissel's head, is a main reservoir holding 290 gallons of thickened napalm. Outside, a Japanese Type 92 heavy machine gun hammers the tank's frontal armor. Inside, the air reeks of ozone and raw fuel. Kissel knows the math better than anyone. One lucky armor-piercing round, one spark from a spalling rivet, and the 30-ton tank doesn't just explode, it becomes a blast furnace, incinerating everyone inside instantly. He is riding in a mobile bomb, and the trigger mechanism is a prototype revolver switch he wired himself in a garage back in Hawaii. To understand why a Navy electrician agreed to climb inside a suicide tank when the Marines refused to advance without it, we have to go back to the moment the Pentagon realized their math was wrong. The calculation for taking Iwo Jima was supposed to be a standard amphibious assault equation. Tonnage of naval gunfire divided by square yards of sand equals victory in 3 days. But by February 1945, the Pentagon's math had collided with General Tadamichi Kuribayashi's geology. The Japanese commander had realized that fighting on the beaches was suicide, so he did something unprecedented. He turned the island itself into a weapon. Kuribayashi hollowed out Mount Suribachi and the northern plateaus, constructing 11 miles of reinforced tunnels connecting 750 major pillboxes. These weren't hasty foxholes. They were engineering marvels of reinforced concrete buried under 10 feet of black volcanic ash. When the U.S. Navy bombarded the island for 3 days, the shells didn't crack the defenses. They simply rearranged the landscaping. When the Marines hit the beach, they weren't fighting an enemy army. They were fighting a ghost. The Japanese defenders would open fire from a concealed aperture, pin down a Marine platoon, and then vanish into the earth before artillery could zero in. The only way to kill a defender you couldn't see, inside a cave you couldn't collapse, was fire. You had to physically push a wall of heat deep into the tunnel network to suck out the oxygen and incinerate the occupants. The Marine Corps knew this. They had brought the standard tool for the job, the M2 portable flamethrower. But on the slopes of Iwo Jima, the M2 was less of a weapon and more of a death warrant. To operate an M2, a Marine had to strap 2 heavy steel cylinders filled with 4 gallons of fuel to his back. The entire rig weighed 70 pounds. In the soft volcanic ash, which had the consistency of loose coffee grounds, a man carrying that load couldn't run. He could barely walk. He was a slow-moving, high-contrast target. Japanese snipers were trained to identify the twin tanks instantly. They didn't aim for the man. They aimed for the tanks. A single incendiary bullet turned the operator into a human torch. Even if he survived the approach, the weapon itself was pitifully underpowered. The M2 had a range of maybe 20 to 30 yards and a firing duration of 7 seconds. To use it, a Marine had to stand within grenade range of a machine gun nest, expose himself, and pray the fuel stream didn't drift in the wind. In the first days of the battle, the casualty rate for flamethrower operators in some battalions hit 92%. It was unsustainable. The Army had foreseen this problem. They knew infantry needed armored support, so they had deployed their own mechanized solution, the Satan flame tank. On paper, the Satan looked like the answer. It was a modified M3 Stuart light tank with a flamethrower mounted in the bow. But in the harsh reality of the Pacific, the Satan was a failure of engineering imagination. The M3 Stuart was a light tank in the truest sense. Its armor was barely an inch thick. The Japanese Type 147mm anti-tank guns, concealed in the rocks, punched through the Satan's hull like a hole punched through cardboard. Worse than the armor was the weapon itself. The Satans used the Ronson system, a modification of the Canadian Ronson flamethrower. The Ronson relied on compressed gas to propel standard liquid gasoline. Here lies the critical failure in physics that the military engineers had overlooked. When you spray liquid gasoline under pressure, it atomizes immediately upon leaving the nozzle. It creates a massive, spectacular rolling ball of fire. It looks terrifying in newsreels, but tactically, it is flawed. The fire burns up most of its energy in the air before it ever hits the target. It lacks mass. It lacks momentum. When a Satan tank fired at a Japanese bunker, the flame would hit the concrete face and billow upwards in a cloud of black smoke. It didn't have the kinetic energy to punch through the firing slit. The Japanese gunners inside would simply close the steel shutters, wait for the fire to burn out, and then resume killing Marines. The Ronson had a maximum effective range of roughly 60 yards better than the infantry, but still well within the kill zone of Japanese anti-tank teams. The invasion force was trapped in a lethal stalemate. The infantry couldn't get close enough with satchel charges without getting cut to pieces. The portable flamethrowers were suicide missions. The light tanks were getting knocked out, and the standard Sherman tanks with their 75mm cannons were useless against bunkers buried under 20 feet of rock. Back at Schofield Barracks in Hawaii, Colonel George F. Unmacht of the Chemical Warfare Service was reading the after-action reports with growing fury. Unmacht ran a unit that existed on the fringes of Army doctrine, a skunkworks of chemical specialists and engineers. He saw the data clearly. The Ronson system was a dead end. You couldn't just scale up a garden hose, you needed a fire hose. Unmacht realized that to crack the caves of Iwo Jima, the Marines didn't need a flamethrower. They needed a naval cannon that fired liquid instead of steel. They needed a system that could shoot a cohesive rod of fuel 150 yards, with enough pressure to ricochet off the back wall of a cave and splash around corners. But to build a weapon of that magnitude, you needed a massive pump. You needed hundreds of gallons of fuel. You needed heavy armor to survive the delivery. You needed, in short, to gut a main battle tank, the M4 Sherman, and turn it into a dedicated flame machine. The Marine Corps brass hated the idea. To a tank commander, the 75mm main gun was his life insurance. It was the only thing that could kill enemy tanks. Unmacht was proposing to rip out the main gun and replace it with a tube that shot jelly. They called it a gimmick. They argued that removing the main cannon would leave the tank defenseless and the crew vulnerable. They wanted the Seabees to stick to building runways and latrines, not redesigning armored warfare. But Colonel Unmacht had an ace up his sleeve. He had the 117th Naval Construction Battalion, the Seabees. And hidden within the ranks of these construction workers was a 4-year-old electrician who looked at the Army's blueprints, saw the failure of the Ronson system, and decided he could build something better out of junk. That junk was scattered across the concrete floor of a restricted hangar at Schofield Barracks, headquarters of the Joint Chemical Warfare Service. This was Colonel Unmacht's personal fiefdom, a place where the Army's rulebook went to die. Unmacht didn't rely on Ordnance Department bureaucrats in Washington who had never heard a shot fired in anger. He relied on the 117th Naval Construction Battalion. These weren't fresh-faced conscripts struggling through basic training. The Seabees were master tradesmen, union electricians, high-steel welders, heavy machinery operators recruited straight from civilian construction sites. They were older, they were cynical, and they possessed the specific kind of arrogance that comes from knowing you can build a suspension bridge out of scrap metal if given a weekend and enough coffee. Among them was electrician's mate second class Joseph Kissel. Kissel and the team, led by Unmacht, attacked the problem from the molecular level up. The first step was ditching the liquid gasoline used in the Satan tanks. Liquid gas is volatile and burns too fast. Unmacht's chemists introduced a secret powder, a mixture of aluminum naphthenate and aluminum palmitate. When mixed with gasoline, it created a viscous, sticky gel. They named it by combining the ingredients, napalm. This napalm changed the physics of flame warfare. It didn't atomize in the wind, it held together. When fired under pressure, it acted less like a mist and more like a fire hose shooting a solid rod of jelly. It could travel 150 yards, triple the range of the Ronson system, and it carried enough kinetic energy to smash through the firing slit of a pillbox before igniting. But propelling this heavy gel required massive pressure, far more than compressed gas bottles could provide. The Seabees needed a mechanical pump, industrial piping, and huge reservoirs. And this is where the heresy began. To fit the system, Unmacht ordered his team to do the unthinkable, strip the 75mm main gun out of the M4 Sherman. To a tanker, the 75mm gun is sacred. It is the tank's reason for existing. It is the only thing that can kill enemy armor. Unmacht ripped it out and replaced it with a hollow dummy barrel that concealed the high-pressure flame nozzle. But the real madness was where they put the fuel. There was no room for external tanks that wouldn't be instantly shot off. So, the Seabees gutted the internal ammunition racks and installed 4 massive fuel reservoirs inside the crew compartment. Think about that for a moment. In a standard Sherman, the crew sits surrounded by steel armor designed to keep dangerous things out. In Unmacht's prototype, officially designated the CBH-1, CB Hawaii 1, the crew sat surrounded by 290 gallons of napalm. They were literally sitting inside the bomb. The mechanical engineering was brutal, but the electrical engineering was a nightmare. That was Joseph Kissel's war. The CBH-1 wasn't just a pump, it was a complex hydraulic system that needed to be controlled from the turret. Kissel had to wire over 1,000 separate electrical connections into the cramped, vibrating steel hull of the Sherman. He wasn't working with aerospace-grade connectors. He was using standard naval surplus, soldering irons, and electrical tape. The biggest technical hurdle wasn't moving the fuel, it was lighting it. Standard spark plugs, the kind used in car engines, failed miserably. The thick, sticky napalm coated the electrodes, fouling the plug and preventing a spark. If the igniter failed in combat, the tank would just spray raw fuel at the enemy, useless and suicidal. Kissel and the machinists devised a solution that was pure mechanical genius. If one spark plug would foul, they wouldn't use spark plugs. They built a waterproof cylinder that housed a rotating cluster of matches magnesium-based ignition cartridges. It functioned exactly like the cylinder of a revolver. When the gunner pulled the trigger, an electrical solenoid rotated the cylinder, aligning a fresh match with the fuel stream. It struck, ignited, and sent a burning charge into the napalm rod. If it missed, the cylinder spun again. It was a mechanical failsafe built by guys who knew that technology always breaks when you need it most. Kissel tested the mechanism 40 times in the humidity of Hawaii. It never failed. By November 1944, the 117th had hand-built 8 of these monsters. They were heavier than standard Shermans. They were slower, and to the untrained eye, they looked exactly like normal tanks until you looked down the barrel. The Seabees called them Zippos. The Marines called them ticking time bombs. But as the invasion fleet gathered for Iwo Jima, the question wasn't whether the CBH-1 worked on the test range. The question was whether any crew would be crazy enough to drive a tank filled with liquid fire into the sights of the best anti-tank gunners in the Japanese Empire. But even with the prototype proven, the greatest threat to the CBH-1 wasn't a Japanese anti-tank gun, it was the United States Marine Corps doctrine. When Colonel Unmacht presented the concept to the Pacific Command, the reception was colder than the steel of the hull. General Holland, Howlin' Mad Smith, the father of amphibious warfare and a man who did not suffer fools, looked at the schematics and saw a tactical liability. In the rigid calculus of 1,945, a tank had one primary job: destroy other tanks. The Japanese Type 97 Chiha medium tanks, though inferior to the Sherman, were still a threat. By removing the 75mm cannon, Unmacht was effectively castrating the Sherman. He was turning a main battle tank into a specialized engineering vehicle that was helpless against enemy armor. The logic of the rejection was sound. If a Zippo rounded a corner and ran face-to-face into a Japanese tank, it couldn't shoot back. It had no armor-piercing shells. It had no high-explosive rounds. It had a squirt gun. The Marines argued that they couldn't afford to waste precious shipping space on 8 tanks that might be useless in a tank duel. Furthermore, the safety officers were apoplectic. The CBH-1 routed high-pressure fuel lines directly through the turret basket, the exact space where the commander and gunner stood. A minor leak wouldn't just be a maintenance issue. It would spray pressurized napalm onto the crew. If a spark ignited the fumes, the tank wouldn't just burn. It would detonate with the force of a 1,000-pound bomb. The official verdict was clear. The weapon was too specialized, too dangerous to the crew, and tactically inflexible. But Colonel Unmacht operated on a different frequency. He knew that Iwo Jima wasn't going to be a tank duel. It was going to be a siege. He quietly ignored the pushback, utilizing his independent command authority within the Chemical Warfare Service to continue production off the books. Back in the hangar, the rejection by the brass trickled down to the shop floor, fueling a desperate intensity among the Seabees. They weren't building authorized equipment anymore. They were building contraband. This shifted the burden entirely onto the shoulders of men like Joseph Kissel. Since the weapon wasn't official standard issue, there were no spare parts in the supply chain. There were no field manuals. There were no army mechanics trained to fix it. Kissel's world shrank to the cramping, dimly lit interior of the Sherman hulls. The engineering challenge was trying to marry delicate electrical systems with the brutal violence of a tank. A Sherman tank is a machine designed to vibrate. The 500 horsepower Ford GAA V8 engine shakes the chassis violently. The tracks slamming against the ground create a constant, bone-rattling tremor. For a house electrician, vibration is a nuisance. For Kissel, it was an enemy. A standard soldered joint, perfectly fine in a breaker box, would snap in 10 miles of rough terrain. Kissel had to hand-wire every single one of the 1,000 connections, creating strain relief loops and using heavy-duty insulating tape to cushion the wires against the steel hull. He wasn't just wiring a circuit, he was armor-proofing electricity. He worked 18-hour days, his hands cut and scarred by the sharp edges of the machine steel. The air in the hangar was thick with welding smoke and the chemical stench of the napalm thickener. The Seabees cannibalized parts from wrecked tanks and aircraft. When they ran out of standard conduit, they used whatever tubing they could scavenge. It was a masterpiece of improvisation, held together by welding rods and sheer stubbornness. By late January 1945, the 8 tanks were finished. They were painted olive drab, stenciled with white stars, and designated with a bureaucratic lie, M4A3R5. It sounded official, but it meant nothing. To the supply clerks, they were just Shermans. But as the tanks were chained to the decks of the transport ships, a terrifying realization hit the team. These machines were so complex, so jury-rigged, and so utterly unique that if a single wire vibrated loose on the beach, the entire weapon would be a 35-ton paperweight. The Marine tank crews didn't know how to fix the revolver ignition. They didn't understand the hydraulic pressure curves of the napalm pump. There was only one solution. The warranty for the CBH-1 was Joseph Kissel himself. Orders were cut. Kissel and a fellow Seabee, shipfitter First Class J.T. Patterson, were detached from their construction battalion and assigned to accompany the tanks into combat. This was highly irregular. Navy construction personnel were supposed to build the airfield after it was secured, not storm the beach in the first wave of armor. Kissel packed his tools, his voltmeter, his pliers, his rolls of wire into a canvas bag. He wasn't going to Iwo Jima to shoot a rifle. He was going to ensure that when a Marine commander pulled the trigger, the Dragon actually breathed. As the transport ships steamed toward the Bonin Islands, the Marines on board looked at the strange tanks with the dummy barrels and the electrician who hovered over them like a nervous parent. They saw a suicide trap. Kissel saw the only thing that could dig the Japanese out of the Black Rock. On February 19th, D-Day, the ramp dropped. The 8 unwanted, unauthorized, and terrifyingly fragile tanks rolled onto the soft ash of Yellow Beach, right into the teeth of the most fortified island on Earth. For the first 48 hours, the 8 tanks sat in the staging area near Yellow Beach, ignored by commanders who were too busy trying to keep their battalions from disintegrating to worry about experimental gadgets. The battle for Iwo Jima had instantly devolved into a chaotic, bloody grind. The Marines were measuring progress in inches, paying for each yard of black sand with catastrophic casualties. By the morning of February 21st, D+2, the assault had stalled completely in front of a complex of reinforced concrete pillboxes guarding the approaches to Airfield No. 1. A single Japanese heavy machine gun position had pinned down an entire company of the 4th Marine Division. Artillery shells bounced off the 3-foot-thick concrete. Bazooka teams were cut down before they could get within range. The infantry was trapped in the open, dying. Desperation overruled doctrine. The battalion commander grabbed the radio and demanded those flame tanks be brought up immediately. Joseph Kissel grabbed his tool bag and climbed into the bow gunner's seat of the lead Sherman. He wasn't there to fight. He was there to listen. He needed to hear the pitch of the hydraulic pump and watch the pressure gauges he had wired himself. If the pressure spiked, the lines could burst, spraying the crew with napalm. If the pressure dropped, the stream would dribble out harmlessly. The tank lurched forward, its tracks churning through the loose volcanic ash that had bogged down standard armor. Inside, the noise was deafening, the roar of the Ford V8 engine competing with the sharp clang, clang, clang of Japanese small arms fire hammering the hull. To the Japanese gunners in the pillbox 200 yards away, this looked like just another Sherman. They kept firing, confident that their concrete walls were impervious to the tank's 75mm gun. They didn't know the gun was a lie. At 150 yards, the tank commander, looking through his periscope, traversed the turret. He aligned the dummy barrel with the dark firing slit of the bunker. In a standard engagement, this would be the moment for a high explosive shell. Instead, the gunner squeezed the trigger on the solenoid grip. Deep in the hull, the electric motor engaged. The hydraulic pump screamed. What happened next defied everyone's understanding of fire. There was no billowing cloud of black smoke, no sudden puff of orange flame that dissipated in the wind. Instead, a solid, cohesive rod of thickened orange gel erupted from the barrel at 300 pounds per square inch. It looked less like fire and more like a laser beam made of liquid. The stream crossed the 150-yard gap in less than 2 seconds, ignoring the crosswind that would have scattered a standard flamethrower shot. It slammed into the face of the pillbox with such kinetic force that it didn't just splash. It shattered, atomizing into a sticky, burning mist that coated the concrete. Then, the physics of the CBH-1 revealed their true horror. Because the napalm was a heavy gel, it didn't stop at the entrance. The burning liquid ricocheted off the back wall of the bunker, splashing around corners and flooding the tunnel floor. It clung to everything it touched: equipment, ammunition, uniforms burning at 2,000 degrees Fahrenheit. But the heat wasn't the only killer. The sudden combustion of hundreds of gallons of fuel inside a confined space created a massive vacuum. It instantly sucked the oxygen out of the bunker and the connecting tunnels. The Japanese defenders who weren't incinerated instantly suffocated as the air was ripped from their lungs. The stream cut off. The tank commander released the trigger. Silence fell over the sector. The machine gun that had pinned down the Marine Company for 6 hours was gone. In its place was a blackened, smoking tomb. The entire engagement had lasted less than 60 seconds. Marines peering over the rims of their foxholes stared in disbelief. They had watched men die for 2 days trying to scratch that pillbox. The Ronson tanks they knew would have needed to be right on top of the bunker to work. This new machine had killed the target from outside the range of the enemy's return fire. The radio net exploded. "Get that thing up here. Send the Zippo to the left flank. We need fire on Hill 362. The nickname Zippo stuck instantly. It was a dark joke, a lighter that worked every time, but it carried a newfound reverence. The infantry stopped seeing the strange tanks as liabilities and started seeing them as saviors. For Kissel, sitting in the bow, the relief was physical. The pressure gauges held steady. The revolver ignition cylinder had rotated and fired perfectly. The thousands of soldered connections, vibrating violently as the tank maneuvered over the rock, held fast. The junk he had built in Hawaii was working. But success brought a new, terrifying problem. The Marines realized these 8 tanks were the only keys to unlocking the island. They refused to advance without them. A platoon commander would radio in, "We are pinned down, waiting for Zippo," and simply stop fighting until one of the 8 tanks arrived. The demand was absolute. The tanks began running 4, 5, 6 missions a day. They were shuttled from one hot spot to another, never cooling down, never resting. The barrels grew so hot they blistered the paint. The hydraulic pumps whined in protest. And inside the hulls, the crews were breaking. Operating a flame tank on Iwo Jima was like working in a blast furnace. The ambient temperature outside was moderate, but inside the steel box, surrounded by the engine heat and the friction of the hydraulic system, temperatures soared to 130 degrees. The air was foul with the fumes of napalm and cordite. Men passed out from heat exhaustion while driving. And through it all, Joseph Kissel kept the machines alive. When a tank returned to the rally point to refuel, a dangerous, manual process of hand-pumping 290 gallons of napalm into the hull while under mortar fire, Kissel was there. He wasn't sleeping. He was tracing shorts in the electrical loom. He was replacing fouled ignition cartridges. He was tightening hydraulic fittings that had worked loose from the recoil. He knew that if he stopped, the tank stopped. And if the tank stopped, the Marines on the ridges died. But the Japanese defenders were not passive victims. They were veterans who adapted quickly. They saw the rod of fire and understood exactly what it meant. General Kuribayashi issued a new standing order. Forget the infantry. Forget the standard Shermans. Kill the Zippos. By D+5, the Japanese anti-tank gunners had stopped shooting at the lead tanks and started waiting. They were hunting the flame tanks specifically, looking for the telltale dummy barrel. And they weren't just using guns anymore. Suicide squads began emerging from the spider holes, clutching satchel charges and magnetic mines, sprinting through the smoke with one objective: get close enough to the steel hull to crack it open and light the 290 gallons of fuel inside. The Japanese strategy to kill the Zippos shifted from brute force to surgical precision. Snipers and mortar teams began ignoring the tanks themselves and focusing entirely on the logistical umbilical cord, the refueling trucks. Every flame tank consumed nearly 300 gallons of napalm in a single engagement. To keep the 8 tanks fighting, the Seabees had to constantly shuttle fuel forward in soft-skin trailers and jerry cans. These refueling points became kill zones. Japanese observers on the high ground would wait for a Zippo to retreat for fuel, then saturate the area with knee mortar shells, hoping to ignite the volatile mixture while it was being hand-pumped into the tank's hull. This targeted harassment turned maintenance into a combat patrol. Joseph Kissel wasn't just a mechanic anymore, he was a high-value target. By D+10, he was operating in a state of fugue-like exhaustion. He had been on the island for over a week, surviving on 3 hours of sleep a night, often curled up on the steel floor of a tank or in a foxhole dug beneath the treads. The environmental conditions on Iwo Jima were destroying the delicate electrical systems he had built. The fine, abrasive volcanic dust, black and grit-heavy, worked its way into everything. It coated the relay contacts of the ignition solenoids, preventing the circuit from closing. It clogged the hydraulic valves of the main pumps. Under normal Army regulations, these tanks would have been pulled off the line for a complete overhaul. But there was no line to pull back to. The demand was insatiable. Kissel had to improvise repairs in the field, often while the tank was still warm from a mission. When standard copper wiring ran out, he scavenged telephone wire from the signal core to bypass corroded circuits. When a fuel pump gasket blew on tank number 4, he fabricated a replacement from a piece of rubber torn from a wrecked truck tire. He was the only human being on the island who understood the labyrinth of 1,000 connections inside the hull. If he stopped moving, the flame tanks died. And if the flame tanks died, the assault on the north stopped. The vindication of his garage logic came at the most infamous sector of the island, the meat grinder. This was a defensive complex formed by 3 features: Hill 362, Turkey Knob, and the amphitheater. It was a bowl of death, where the Japanese had overlapping fields of fire from hundreds of cave entrances. The 4th Marine Division had thrown themselves against it for days, suffering horrific casualties for zero gain. The stalemate was absolute. On March 3rd, the call went out. 4 Zippos were assigned to crack Hill 362. Kissel rode in the lead tank again, monitoring the pressure. As the Shermans rumbled into the valley, the Japanese opened up with everything they had. But the Zippos didn't need to see the enemy to kill them. They simply began painting the cliff face. The 4 tanks unleashed 1,200 gallons of napalm in a coordinated barrage. The burning gel didn't just hit the cave entrances. It flowed down the ravines and pooled in the trenches. It turned the complex geology of the meat grinder against the defenders. The fire sucked the oxygen out of the entire ravine. Secondary explosions erupted as Japanese ammunition caches cooked off inside the tunnels. In 12 minutes, the Zippos accomplished what an entire Marine division had failed to do in a week. When the infantry finally advanced up the slopes of Hill 362, they didn't face a wall of machine gun fire. They walked through a silent, smoking moonscape. The psychological impact on the enemy was shattering. Japanese prisoners, who were indoctrinated to fight to the death against bullets and bayonets, began surrendering the moment they saw the rod of fire. The primal fear of being burned alive broke the Bushido code where high explosives could not. Diaries recovered from Japanese officers described the tanks that shoot liquid hell with a reverence usually reserved for natural disasters. By the 4th week of the battle, the vindication of Colonel Unmacht's heretical project was total. The 8 tanks built from scrap, rejected by the brass, and driven by electricians, had become the most valuable assets in the Pacific theater. The statistics were staggering. In 28 days of continuous operation, the Zippos had conducted over 240 combat missions. They had burned out an estimated 370 fortified positions. They had consumed 140,000 gallons of napalm. But the most important statistic was the one the Marines cared about. In sectors where flame tanks were used, Marine infantry casualties dropped by over 40%. Thousands of men who would have been cut down charging a pillbox were alive because Joseph Kissel had wired a revolver mechanism to a hydraulic pump. The ripple effect was immediate. The Marine Corps, which had initially scoffed at the idea of removing a tank's main gun, suddenly couldn't get enough of them. Orders were flashed from Iwo Jima back to Hawaii and Washington. Send more. The CBH-1 was no longer an experiment. It was the new doctrine of siege warfare. But for Kissel, the victory wasn't in the change of doctrine. It was in the faces of the 9-year-old Marines who would walk past his tank, pat the warm steel of the hull, and say, "Thanks, Mac." He had kept the dragons breathing for 36 days. And as the island was finally declared secure, the military-industrial complex prepared to take the junk he had built and turn it into a standard-issue weapon for the next invasion. That junk became the blueprint for the deadliest siege weapon of the 20th century. Before the smoke had even cleared over Mount Suribachi, the United States military establishment, the same colossus that had initially rejected the flame tank as a dangerous gimmick, scrambled to clone Joseph Kissel's work. For the invasion of Okinawa, slated for April 1st, 1945, the Army didn't just request a few more specialized tanks, they converted an entire unit. The 713th Tank Battalion, previously a standard armored outfit, was pulled off the line and retrofitted exclusively with the CBH-1 system. They didn't deploy with 8 tanks, they deployed with 54. This was the industrialization of the skunkworks. The 713th Armored Flamethrower Battalion became the only unit of its kind in the Pacific War, and they operated using the exact hydraulic schematics and wiring diagrams Kissel had drawn up in the hangar at Schofield Barracks. On Okinawa, they didn't just support the infantry, they led them. The battalion consumed over 200,000 gallons of napalm in 82 days of combat, burning their way through the Shuri line with a systematic efficiency that terrified even the most hardened Japanese commanders. But the legacy of the Zippo extends far beyond the volcanic islands of World War II. Kissel's fundamental insight that a flame weapon must be a main gun system firing a cohesive liquid rod rewrote the physics of mechanized warfare. If you look at the M67 Zippo tank used by the Marines in Vietnam 2 decades later, you are looking at the direct descendant of the CBH-1. The chassis had changed from a Sherman to an M48 Patton, and the electronics were military-grade rather than scavenged naval surplus, but the soul of the machine was identical. It was still a main battle tank with its cannon removed, pumping thickened fuel under high pressure to dislodge an entrenched enemy that could not be reached by conventional ballistics. The deeper truth of this story isn't just about a clever invention. It is about the brutal evolution of problem-solving in war. Before the CBH-1, the American approach to a fortified bunker was to throw men at it until the enemy ran out of bullets. It was a strategy of attrition, paid for in blood. The CBH-1 represented a shift to a strategy of technological overmatch. It proved that the correct application of fluid dynamics and mechanical engineering could save thousands of infantrymen from the suicide mission of corking a cave with a satchel charge. Joseph Kissel, the man who sparked this revolution, didn't stay to see his invention become doctrine. After 32 days of combat and countless improvised repairs under fire, he quietly rotated back to his construction battalion. He wasn't a tanker, and the war was over for him. He returned to the anonymity of the Seabees, trading his voltmeter and hydraulic wrench for the tools of peacetime construction. There were no parades for the electricians. The crews of the flame tanks received presidential unit citations, and rightly so, but the man who had hand-wired the nervous system of the beast simply went back to being an electrician's mate. He had no way of knowing that the suicidal machine he built would remain in the U.S. arsenal, in one form or another, until the very concept of flame warfare was retired from service. He had solved the impossible equation of Iwo Jima. He had proven that when the paper pushers said a thing couldn't be done, and the experts said it shouldn't be done, a tradesman with a welding torch and a refusal to accept the stalemate could change the course of history. As the Zippos of the 713th burned the last resistance out of Okinawa, the Pacific War moved toward its atomic conclusion. The flame tank had conquered the caves, but the United States Navy was simultaneously facing a threat that came not from under the ground, but from the sky. A threat that would require an even more complex, desperate, and secret technological solution than the CBH-1. But that is a story for another dossier. For Joseph Kissel, the war ended not with a bang, but with the quiet satisfaction of a job, however horrific, done right. That job was finished when Joseph Kissel handed in his tools and walked off the transport ship, leaving the dragons behind him. He returned to a civilian world that was rapidly trying to forget the smell of burning sulfur and the blackened scars of Iwo Jima. He didn't write a memoir. He didn't tour the war college circuit to lecture generals on the efficacy of hydraulic pressure in siege warfare. He simply went back to work, an anonymous tradesman in a country rebuilding itself from the ashes of global conflict. But the silence of his post-war life belies the magnitude of what he achieved. In the grand calculus of the Pacific War, Joseph Kissel is a statistical anomaly. He was a single, enlisted man, operating without a budget, without official sanction, and often against the direct orders of the military hierarchy. Yet, his garage logic saved more American lives on Iwo Jima than entire battalions of conventional armor. The lesson of the CBH-1 is not just about the effectiveness of napalm. It is a testament to the friction between doctrine and reality. The experts in Washington looked at the problem of the Japanese caves and prescribed a solution that fit their rulebook: the standard flamethrower. It was neat, it was standardized, and it was useless. Kissel looked at the problem and built a solution that was ugly, dangerous, and heretical, but it worked. He proved that in the crucible of war, the most dangerous weapon isn't the one with the biggest caliber. It's the one built by the man who refuses to accept that it can't be done. He demonstrated that sometimes the only way to save the men on the front line is to ignore the men in the rear. While the CBH-1 conquered the Earth, the Pacific War was evolving into a final, terrifying phase in a different domain. As the Zippo tanks cooled on the slopes of Suribachi, the invasion fleet offshore was facing a new threat, a suicide weapon that didn't crawl out of a tunnel, but fell from the sky: the kamikaze. To stop a pilot who didn't care if he survived, the Navy would need a projectile that didn't need to hit its target to kill it. They needed a shell with a brain. This is the story of the VT-Fuse, the top-secret smart bullet that was illegal to fire over friendly territory for fear the enemy might find a dud and copy the technology. That is the story of the second impossible innovation that saved the fleet, and we will declassify that file in our next operation. If you believe that the stories of men like Joseph Kissel, the innovators who built victory with their bare hands, deserve to be remembered, make sure you are subscribed. Click the like button to help this briefing reach more people, and leave a comment below. What other field modifications or forgotten tech from World War II should we investigate next? I'll see you in the next briefing. Dismissed.